This video is going to look at example 2 from section 1.5, solving equations and inequalities by graphing. This is going to focus on just the inequalities part. So remember that when we have inequalities, we're looking for a range of values that fit that definition. And so when we learned how to do this with equations, we started with each side of the equation and graphed them separately. With the inequality, that's going to start the same as well. So what I'm going to do is I'm going to take the left-hand side of my inequality, which is x plus 3, and make that into a y equals equation so that I can graph it. And so this equation, y equals x plus 3, is telling me to graph a line that has a y-intercept at 3 and a slope of 1, because there's a 1 in front of my x. And so I'm going to graph that line. And then I'm going to graph the line on the other side as well. And again, the points of intersection are going to help me here. So this line is 7x minus 3. So y equals 7 minus 3x. I said that wrong. 7 minus 3x. Since that's not really in y equals mx plus b form, I want to think about it as negative 3x plus 7. And so that tells us to plot a y-intercept of 7 and then a slope of negative 3. So we're going to go down 3 over 1. Notice that first point gives us that point of intersection. And so our line is going to look like this for 7 minus 3x. And so this one's a little bit different because we're talking about an inequality. And so when I'm looking at x plus 3 is greater than 7 minus 3x, what I want to find is the answer is going to be the part of the domain where that graph for y equals x plus 3 is above the graph for 7 minus 3x. So I want to find the part of the domain where x plus 3 is above 7 minus 3x. So since I have colors, I want to find the part where my red is above my blue. And so again, it's above, the one that's above is going to be the one that is greater. So this greater tells me I want that part to be above. And so where this is going to occur, the division is going to occur always on that point of intersection. So what we can see is that on the left side of the graph, the 7 minus 3x is actually greater than x plus 3, right? This is the side that's above for every point. So my line visually, the blue line's on top, versus on the right-hand side here, is what I want. X plus 3 is greater than 7 minus 3x. This is the part that's above. So all the points on this are above all the points on the blue, versus when they intersect, that's where they're exactly the same. And so what I need to do is I need to write this domain using these values. And so my inequality here is actually going to always occur in the problem. So what I know is I'm talking about x because I'm talking about domain. And I know whatever value is going to occur is going to happen at 1 because they intersect at the point 1, 4. And so let me color code that 1 to be green so that we can kind of see that. And so when I write my answer this way, the side of the graph really tells me what my inequality is going to be. So if I look on my blue line, this side is where the red line is above the blue line, where x plus 3 is above 7 minus 3x. And so these numbers are all greater than 1. And so my inequality is going to be that x is greater than 1. Because I didn't have an equal to in the original problem, I don't have an equal to in my answer. So instead of my answer just being x equals 1, as it was if that was an equal sign here in between, we have x is greater than 1, because the right side of their point of intersection is where the red line is now above the blue line. So let's look at this a little bit differently in terms of a quadratic. So for the second problem, we have x squared plus 6x plus 5 is greater than or equal to 0. And so what we have to do here is graph the quadratic y equals x squared plus 6x plus 5. And so remember that to do that, to find the value for h, we're using the formula negative b over 2a, where a is the number in front of x squared, so in this case 1, and b is the number in front of x, so in this case 6, and if we needed c, that's going to be our y-intercept at 5. And so what this tells us is that the h coordinate of our vertex, so the x value in our vertex is 6 over 2, negative 6 over 2, which is negative 3. Okay, so when I plug in negative b, so negative 6 over 2 times a is 1, I get negative 3 for the x coordinate of my vertex. So I know that my parabola is going to be centered around negative 3. To determine k, what I have to do is plug that value in. So I've got my equation x squared plus 6x plus 5, and I'm going to take that value negative 3 and plug it in for x so that I can determine what the y coordinate of the vertex is, what the k value is. So negative 3 squared is 9, plus 6 times negative 3 is negative 18, plus 5. So these two are going to give us negative 9 plus 5 is negative 4. So this tells us that the vertex is negative 3, negative 4. And so that's going to be the first point that we plot for this graph. So negative 3, negative 4. The value for A tells us that there's no vertical stretch or compression. And so we're just going to go out 1 up 1, out 1 up 3, out 1 up 5, our odd number pattern, because it's just a parabola with an A of 1. Okay, so from here we're going to go out 1 up 3, out 1 up 3. And then the next gap would be 5 units. We can draw that in as an estimation since it's only one above where our graph goes. So the first equation that we graphed in this inequality is the parabola x squared plus 6x plus 5, which would be equivalent to the parabola y equals 1 times x plus 3 squared minus 4 in vertex form. So remember that for your test and your review. I'll give it to you in vertex form, so you need to be able to go from vertex form to identifying the vertex. You don't need to memorize that formula to get h from standard form. So that idea would make this problem a little bit shorter because it's easier to graph from vertex form. The other side of our inequality is easy. It's just y equals 0. So remember that means that we're looking at y equals 0x plus 0. And so this has a y-intercept of 0 and a slope of 0. So I'm going up none over 1, up none over 1. And so notice that this line is really just the x-axis. So my points of intersection are these 2 points here. So it's at, I'm going to write this over here. So my graphs intersect at negative 5, 0. And at negative 1, 0. And so the question is asking us, again, for an inequality. Notice that we have greater than or equal to. And so that means our answer for x is going to have greater than or equal to. So it's saying that it wants this one to be the one that's above. Okay, so whichever one that it says is greater. Remember the trick you learn with crocodiles is that if it always wants to eat the larger thing. So it's going to eat the part that's above. And so I want the parabola to be above the blue line, which if we connect this back to what we learned at the very beginning of this chapter, this is the positive section of that graph. And so notice that through my points of intersection, and since we had 2 again, it's here and here where the graph for the parabola is above the graph for the line, versus in the middle section, we can see that the parabola is below the line. Okay, so we want to write that as our inequality. So this is, we can see that this has x less than or equal to -4. Notice that this arrow here matches the inequality that I wrote, and that works every time when I'm writing x first. And so here, the numbers that I highlighted are all bigger than -1. So that means x is greater than or equal to -1. And again, notice that the arrow, the way that it's pointing, matches my inequality. And then I have to have the equal to because it was given to us in that problem. So that's graph solving inequalities by graphing. We're looking for which section of the graph we want to be above the other section. And then we write our answer using the x values that match that description.